for sensitivity analysis, we have two types, or it can be done in two ways, or we have two categories of sensitivity analysis. We have the first one, that's the changes in the right hand side values, that's the BI values, and then we have the second one, that's the first one is changes in the BI values, and the second one is changes in the coefficients of the objective functions. Changes in the objective function coefficient, that's CJ. Yes. And in our previous video, we discussed this one. We solved examples under that one. That's changes in the right hand side. So in this video, we are going to look at changes in the objective function coefficient. And in the objective function, we have all the variables in it. So let's look at when this can be done in two ways. When the variable that you are changing the coefficient is a non-basic variable, and then when the variable you are changing its coefficient is a basic variable. So these are two cases under the changes in the objective function coefficient. We are going to look at that, and then we see how whenever there is a change in the coefficient, how does it affect the optimal solution. So let's take this example. This is the optimal solution of an LP problem solved using the simplest method. So this is an optimal solution for a particular problem. So we are going to do a sensitivity analysis on it. So we are going to do two analysis on it. That's when the variable is a non-basic variable and then a basic variable. So let's look at this. For instance, we have this table, and then introducing an increase in the value of C2. So this is C1 and then this is C2. So introducing a change in the value of the C2. But let's look at C2. You see this x2. That's the coefficient of x2 in the objective function. But x2 is not in our basis here, which means that x2 is a non-basic variable. S2 is a non-basic variable. Yes, so let's look at how to do that when there is a change in the coefficient of a non-basic variable. So this is simple. You just add delta to the C2 value, and then it take effect in the subsequent calculation. So let's do that. Let's redraw our simplex table. All right, let me bring my table. So writing our values, this will be my basis, and then CB here, and then CJ here. This BI, X1, X2, S1, S2, so 0, 0. But then this one we are considering a change in the C2 value. So that will be 4 plus delta, and then we maintain our 6. Then our BI, so S1, X1, we have 4 here, 0, 1, 4, 1, 1, 0, minus 1 on 2, 1 on 4, and then we have 0, 6. So let's calculate for our ZJ values. I think it's going to be the same. It's our CJ minus ZJ value that's going to change. So 24, 6, and this one is going to give us 6. Still have our 0 here, and then 3 on 2. Alright, so our CJ minus ZJ values, since there is a change in the CJ, which means that there will be a change in the difference as well. So here 6 minus 6 is 0. So 4 plus delta minus 6, that's going to give us minus 2 plus delta. So here will give us 0, and then here will give us 0. But for us to terminate the simplex method, it means that the values for Cj minus Zj have to be sorry, the values for Cj minus Zj have to be 0 or negative numbers, which means that Cj minus Zj is supposed to be less than or equal to 0. When this condition is satisfied, it means that our simplest table is optimal, or we have the optimal solution. So to determine the change, or to determine the value of change for which our solution is going to remain optimal, then we can have this relationship. You can say this one is supposed to be less than 0 or equal to 0. So you can say minus 2 plus delta should always be less than or equal to 0. So from here, we can make delta the subject. So when you make delta the subject, you are going to have delta is less than or equal to 2. But then we know that our value for C2 is equal to, so C2 is equal to 4 plus delta. 4 plus delta. Making delta the subject, we are going to have C2 minus 4. C2 minus 4. So we now put this expression, or wherever we see C2 in this range or this inequality, we replace it by C2 minus 4. So we are going to have this one as C2 minus 4 less than or equal to 2. So we make C2 the subject, which means that we are going to have C2 to be less than or equal to 6. So this is the range for which when we change C2, the solution is going to remain optimal. This means that as long as C2 is less than or equal to 6, the present basic solution remains optimal. This implies that x1 and then s1 will still remain in the basis with their optimal values. S1 and s1 are going to remain in the basis with their optimal values 4 and 4. As long as C2 is less than or equal to 6, and the value of Z is also going to remain the same. There will not be a change in the optimal solution as long as the value of C2, as long as the value here is less than or equal to 6. So there is the sensitivity analysis for a change when you consider a change in the coefficients of a non-basic variable. So that is it. So we are going to look at the second one for, we are done with this. We are going to look at the second one for a basic variable where the coefficient, or where the variable is a basic variable. Let me clear this. All right. So for a change in a basic variable, our basic variable here, let's consider a change in C1. Let's consider a change in C1. A change in C1. This is our C1, 6. So we are going to draw our simplest table again. So we're changing C1. So we are going to have our C1 to be equal to C plus the change. 6 plus the change, sorry. So we are going to draw our simplest table again. Cj minus Cb. Sorry, let me write it well. Cj, and then Cb here, we have our basis, our bi, x1, x2, s1, s2. So this remains 0, this remains 0, this remains 4, but here we are going to replace it with 6 plus the change, and then the coefficient, let's write our basis, s1 and then x1. So the coefficient of x1 is now 6 plus delta, and that of s1 is 0. Make sure you write it, and then we have 4 here, 4, 0, 1, 4, 1, 1 0 minus 1 on 2 minus 1 on 4. So this one will affect. So you should know that when you consider a change in the coefficient of a basic variable, it's going to affect your zj values and your cj minus zj values as well. But then when you consider a change in the coefficient of a non-basic variable, that one, the change is going to appear in only your cj minus zj values. That's just by the way. So let's calculate our zj values. I'm going to have 4 times 0 is 0, 4 times 6, 24, plus 4 delta. That's what we're going to have. And this one is going to give us 6 plus delta. Same here, 6 plus delta. Then this one is going to give us 0. I know you know why we are getting the 6 plus delta and the zeros. 3 on 2 plus delta on 4. Alright, so let's calculate our cj minus zj values. So 6 plus delta minus 6 plus delta, that one is going to give us 0. And then 4 minus 6 plus delta, that's going to give us 4 minus 6, so minus 2 minus delta. And then this one is going to give us 0. And then this one is going to give us minus 3 on 2 minus delta on 4. Alright, so as I said earlier, for our solution to remain optimal, it means that our cj minus zj values are supposed to be less than or equal to 0. If all the cj values satisfy this condition, it means that our solution is optimal. So now we are going to take all the values with the change in it. So, and then wherever we see cj, we replace it by that value, cj minus zj rather. So you have minus 2 minus delta less than or equal to 0, must be less than or equal to 0 for the table to be optimal. And then minus 3 on 2 minus delta on 4 must also be less than or equal to 0 for the solution to be optimal. Alright, so let's make delta the subject for the expressions or for the inequalities. So when we make delta the subject for the first one, we are going to have delta to be greater than or equal to minus 2. And then with this, we are going to have delta to also be greater than or equal to minus 6. The simple algebra. Yes, we should get it. So we have two values for delta here. So we are going to combine this so that we get one range. But we know that our C1 is equal to 6 plus delta. So we make delta the subject here too. So we get delta is equal to C1 minus 6. So you come and substitute this into this. So now we are going to have C1 minus 6 to be greater than or equal to minus 2, and then C1 minus 6 greater than or equal to minus 6. So we make C1 the subject for each of them. Then we are going to have C1 to be greater than or equal to, so minus 6 will go to the other side, minus 2 plus 6, that will be 4. And then we have C1, minus 6 will go, so minus 6 plus 6, that will give us 0. So we have our C1 to be greater than or equal to 4, and we have our C1 to be also greater than or equal to 0. So combining the two ranges, we are going to have, combining these two ranges, we are going to have our C1 to be greater than or equal to 4, which means that this value here, the C1 value, should always be, for the solution to be optimal, the C1 value here should always be greater than or equal to 4. Should always be greater than or equal to 4. So it should be 4 going, 4 and above. If the value of C1 is 4 upwards, it means that our solution is going to be optimal. But any value of C1 less than 4 is going to make our solution not feasible or not optimal. This is the end of this lecture. If you have any question, you can send it in the